So what we've already talked about simplifying radicals, which means what? We have that little symbol. What's under the symbol? Why did they end up under there? What are they supposed to be made up of?
Numbers.
Numbers. I love that. No, they're numbers. We're going to find some letters under there too. So underneath, or how do they get to come out? We are taking the square root of them. If they are not made up of a perfect square, they can't come out and play. They have to stay in the house. All right. So what we are working on, and I really need you all the way with me, are the odds. Obviously, even is homework, but I promise you, you'll have time in class to work on it, but I need you to stay focused with me in case there's a little nuance that you go, wait, I didn't get that. So stay with me. So number one, radical 18. There are several factors that make up 18, but we want one that contains a perfect square so we can remove it. What would that be? Yeah, it's going to be, look at you, already got the answer. But we're going to start with 9 times 2. And then what's removed? The 9. It comes out as what number? 3. The 2, well, I want it to be a perfect square, is not. So it stays underneath. That's your final answer. Okay?
What you said we're doing something different.
We're getting there.
Oh, we're doing that, you gotta find, I can't remember.
Okay, let's keep going. Number 3, we have radical 72.
Wait, so you're gonna break down 9, you put the other, you put 1.
You take 9, and what is it made up of?
3.
3 and 3. So you just remove 1 3 and set it out there, because the way you check your work, if I have that 3 outside, what is 3 squared?
3, 9.
9. So that would put it back inside. And if I had 2 9s out there, 2 3s out there, that would be 81. You would have like 3 squared and 3 squared. I just need 1 to make 9. That way you could come back in and multiply by 2 to get 18. 72, 2 numbers. 9 and 8. So the way I suggest you do it is write the 9 and the 8. Which one comes out? The 9. And I'm making a little playground over here. The 9 becomes a what number? 3. And then keep the 8 underneath. What does it become? 4 and 2. What number comes out? 4 as a 2. This is all about multiplication. Put it up, Robert. We don't need a ruler for anything. So we are multiplying everything we pull out. So 3 times 2 is 6. And then what number had to stay inside? 2.
Wait, why didn't you put the 3 outside for the...
Bless you. Why didn't we do what?
So,
This is the play. I make a little playground, and that's everything we remove goes inside. So we removed the 9. Shh, guys. We removed the 9 as a 3.
so you put 1 on the outside,
And then we removed the 4 as a 2.
put 2 on the outside,
And then we multiply those,
and you got 6.
and that's what goes outside. And that 2, poor thing, can't come out and play. Stays inside. Has to stay in the house.
Okay, I got it.
All right, 80. There's various and sundry ways you can break down 80. 2 factors. Which one? Want to do it? I like 8 and 10 because it's going to show you something. But this isn't the big reveal, but it's one of them. So 8 and 10. Are either of those perfect squares? No. So we're still working with 8 and 10. I'm going to work 8 first. 8 gives us what? 4 times 2. Either of those perfect squares? Our 4. And the 4 is removed as a 2. All right, we still have that 2, but it's just going to travel along, all right? We're not through with the problem. Now we're going to break down 10. And what does that break down to? 5 as well as a 2. Are either of those prime? No, but look what we have. We had this baby 2 that was having to stay in the house. it comes down and we can combine those together and have 2 and 2. What number would that be? 4. And so it would go in as a 2. So let me show you one other way. If we had 8 times 10, knowing everything's under the radical, okay, we're just going to keep that in our mind. And we break 8 down into 4 times 2. And we break 10 down into 2 times 5. You see how that 4 is removed as a 2. We can take these 2 factors and make them into a 4, which gets removed as the other 2. And we're left with what number? 5. How does it what?
After you multiply the two twos, like, why does that make it go large?
Why does it what?
Why does it make it go?
What is 2 times 2?
4.
4. So we still then have a, and remember, all of this is under a radical. All of our work is under a radical.
So you get rid of one, but this one stays.
You get rid of this 4, and it becomes a 2. And when you had 4 times 2 is 8, and 2 times 5 is 10, you can take those 2 2's, one from the 8 and one from the 10, and multiply them to get 4, which is back to a perfect square. So it gets removed from the house 2 as a 2, or also as a 2, and we're left with 4 radical 5. Now let me ask you this. What is 4 squared? 4 squared, not root. 16. What is 16 times 5?
80.
80. And notice that's our number. So you're able to check it by taking the numbers you've removed, that compilation of numbers. Once you've finally multiplied them all together, square what's out there and then multiply it by what's underneath to check. And it gave us 80. Questions before we move on? I'll wait a second for you to look at it and take it in.
So I broke down my 8 and I got 2 and 4 inside the house.
Mm-hmm.
And
To
then
the
2, 4, and 2, 10.
The 4 comes out as a 2. So this one gets removed. And it becomes this 2. Which means we're left with 2 times 2 times 5. 5 isn't going to go anywhere. But the 2 2's can be combined because they're all part of a factor tree. They're all factors. And it becomes, when you combine them, they become a 4, which comes out as your other 2.
Well, where does the other 2 go of the 4?
Okay, let me ask you this. When I have this radical 4, what's your answer? Where's the other 2? All right. It's because you're able to take, each time you have a perfect square, you remove it as one of the factors. And here's why. So when you remove, Sam, the 4 and it becomes a 2 on the outside, let's say we had both of them out there, but we're really going to use just one. What's 2 squared? 4. That gives it to you. There's your answer. But if you'd removed both of them, what's 4 squared? Your number would have been too big. Because if you had removed it and showed both of the numbers, you had both of the numbers showing up, as opposed to just one, your number then would be too big. So you take each clump and represent it one time. All right, number 7. They're not always, and these calculators that I'm hearing click, click, click need to go into the backpack. I didn't say get calculators out. Nobody needs a calculator. We won't call them that, but they were taking the easy road. No, because you won't always have a calculator. So, 128, yes, it's even, which means 2 goes into it, but always look to see if a perfect square will go into it, which let's try 4. And if you look at a number, the last 2 digits is divisible by 4, 4 goes into that number. So 28 is divisible by 4, therefore 4 goes into it. How many times does it go? Lost it. There it goes. It goes in 32 times. So this is going to be, I'm going to do a big, there we go. 4 times 32. Anything, can we remove anything? The 4. What does it become? Where's our playground? 2. All right, then 32. What is that? 8 times 4. Anything removed? What does it become? A 2. 8. What does it become? 2 times 4. What's removed? 4. What does it become? 2. Now, y'all, 2 times 2 times 2 is not 6. Thank you. Don't go 2, 4, 6. 2 times 2 is 4. Times 2 is 8. What's left inside the house?
2.
The 2 right here. So your answer will be 8 radical 2. What's 8 squared?
64.
64 times 2. Oh, look what you get. So you know you've removed it accordingly. Mason.
If we broke it, when we broke it down into 4 and 32, could we break the 32 down into 16 and 2?
Sure, that'd be even quicker.
Yeah.
Yep, absolutely. You can use any of the factors. They'll get you to the same answer. All right. Everybody good with how we got
So what determines if it stays or not?
if it can be broken down into a perfect square? 2. What are the factors of 2? 1 and 2.
So why did you add 8 and 4? 8 times 4. Why did you call it 4? These 4 is already a perfect square.
Okay, but we had 4 times 32, 2 different sets. So that 4
No, not that one. The one that's like 8.
right here,
Yes.
okay, we remove, all right, 8 times 4 are either of those perfect squares.
Yes.
Which one? 4. It gets to remove as a 2. It gets to come out. It's like you're looking at this. Are either of those perfect squares? Yes. So we have a 2. So that one's all the way gone. And then 8 is made up of 2 and 4. Either of those perfect squares. Ugh.
2 and 4.
2 and 4. So then the 4 is, the 4 is removed. The 4, boy, it's grabbing everything. The 4 is removed. Let's go there. There we go. As your other 2. And then 2 times 2 is 4, times 2 is 8. This 2 that's left behind isn't made, it can't be broken down any further. Because the only factors of 2 are 1 and 2. Even 6. 6 would stay underneath because it's only made up of 3 and 2, and neither of those are perfect squares. Matt Miles, thank you. All right, number 9. Number 9. Look at those last 2 numbers. What goes into 512?
428.
4. Oh, wait, what? Hold on. I want to, let's see. You said 4 times what? 4 times 128? What number did we just do?
128.
What? So we gotta get to use what we just did. This won't always happen. But notice what's outside the 128. A 7. So I am making our playground over here.
So you get 6 off.
This is important that you see. This 7 just jumps over into the playground immediately. Okay? Because it's already out there and you can't ignore it. Underneath, you've put a 4. What does it do? It becomes a 2. Now, if you didn't notice 128 as being the answer for 7, then we could keep working it. But if you do notice it, what would go in the playground?
8.
An 8. And what would go underneath?
2.
2. So what would go outside? Final answer.
112.
Yeah. 112, radical 2. You were lucky that number 7 was 128. Because that would be kind of a big one to work.
Wait, so-
Miles,
I have a question.
you sure?
Yeah, I got a question.
Caleb?
So, it's 112 squared times 2 to find.
Mhm. All right, I hear a calculator clicking. Who has it? It's fine, but who has it? Because I have a question for the person holding the calculator.
Who has it?
I think it's the pen.
Okay, I'll use it then. I was going to get y'all to work it for me.
I was Rose.
So when I say 112 squared,
Because we used that. Like, we already had that for the
So that doesn't make it.
no, hold on.
Yeah, it's not right.
That's not going to, that may take us too big. No, no,
What?
112.
112 times
Hey, you
100.
got no earrings. I ain't even got my ers first
It
yet.
doesn't work though.
I did
I
the
got
wrong.
no earring. I ain't got any no earrings. I ain't they brand new. I ain't got my whatever is first yet.
Hmm.
You got the earrings. Nah, you got the inner square. There you go. I got the earring. I ain't got my air pair yet.
Oh, yeah, it does.
I ain't got with it. Ers.
Because you are not going for 512.
Where do you go?
49. That 7's out there. You have to square the 49. I mean the 7 to get 49.
So it's already worked, you just gotta simplify it even more, basically, is what
Mm-hmm.
you're doing there? Okay.
Yes. So Caleb was going, it doesn't work when you square it. You would take the 7 and square it. So you would have 49 times 5, because 512 is really needs to be broken down further. Okay, so 16, 256. Mm-hmm.
It's like 50.
256. When I did 16 squared and multiplied it by 2, I got 512. All right. Because your number's really larger than 512 because you've got that 7 out there.
So, my answer was right.
All right, 11. You tell me what 11 is.
Negative 40.
Mm-hmm. Negative 48. 64 is a perfect square. And it's a perfect square of what? 8. And then you multiply it by negative 6, so negative 48. All right, good thus far. All right, I want you to look at the back page. 13 and 15, you hop on those. And then we need to talk about the simplifying with absolute value signs. So guys in the back, shh. You need like a hint at what might?
Yes. Yes.
72.
Try this number
Which one? 52.
for both of them.
Was that 72 or 52?
Which number?
Yeah.
The odds on the back, 13 and 15.
Was that 52 or 7? That's a 7.
52.
Wait, is that 52?
What?
That's just a W with 3 like earrings. Oh, you got double W. You catch W's.
I didn't know you were cool like that. Double W.
Oh, I am so not. It is.
Bro, no, it's not.
Who said that?
That was me.
So what'd you get for 13? Oh, hop. Like
Hey,
what?
Rose, you use his calculator.
Negative 14, rad 6.
Oh, he said
Why?
Why, Mason?
I
How
can't
you know
repeat
why?
what you just said. Because he's really good at math.
Why? Why is he good at math?
Hey guys, we need to get this part, because we want you to understand the latter part.
Yes, ma'am. I just thought
All right, so 294, I gave you the huge hint that 7 would be your friend. So we're going to go 7 times, and I think it's 42. And I'm going to,
4 and 9.
hold on just a second. So I'm going to make this bigger to include it all. Are either of those perfect squares? No, but 42 breaks down into
9.
7 times 6. So look, we have 2 7s. What do they break down? That's a perfect square. This is 49. So I can remove that as a 7. We already have in our playground the -2 from this part right here. 6. What does 6 break down into? 2 and 3. Are either of those perfect squares? So what's going to stay underneath 6? So -2 times 7 is -14, rad 6. Sam?
Could you not break it down? Could you not break 42 down to 4 and 9? And already have perfect square 4?
49 is 36. Yeah, I know. It'd be great if it would. Okay, so I told you that 7 works for the other one as well. So 98, what does it become? 7 times? And then 14 breaks down into 7 times 2. And then that, look, we've got those 7s beside each other again, which equals 49. And that breaks down to a 7. And we already have a -7 hanging out in the playground. So what's our final answer for 15? -49, red 2. Is this making sense?
Yes.
All right. Now let's talk. Yes, sir.
How are you finding like the number inside the radical? Like what makes it so bad?
Factor trees, looking at divisibility rules. You could have started with 2. You just got to pick factors and try them and see if you don't know which one. Just knowing your divisibility rules. 9 plus 8 is 17. 2 won't go into it, therefore 6 won't. Therefore 9 won't. It doesn't end in a 0 or a 5. 2 goes into it, so you could have started there and just go until you can combine things to make them work. All right, number 17. Notice the directions say use absolute value signs when necessary. What does an absolute value bar look like? Yeah, very good. Just like this. What does it mean if a number's inside an absolute value bar?
Can't be negative.
It can't be negative. If we have a negative inside the absolute value, inside the radical, what do we know that number is?
Imaginary.
It's imaginary. And we are not going for imaginary numbers. So what we need is everything has to come out as a positive number. All right? So stay with me. 17. We will work with numbers, and then we'll come back and talk about variables. So every time, just ignore the variables and figure out your numbers, and then work accordingly. All right, so, come on. Nope, it's not going to let it grow. And I don't think it'll do it here either. Nope. So 448. Do what? 4 and 112. Okay, let's go with that. I'm going to do me a big radical. 4 times 112. What happens to our 4? It becomes a 2. All right, again, 112. It ends with a 12, so we know 4 will go into it because it's divisible by 4. Remember the last 2 numbers, if that's divisible by 4, then the whole problem is. So how many times?
30. I think I got it. 28. 32.
think it's 32. No. My bad.
I got 256 when we do it like that.
Hold on. 28. I went backwards in my brain. Thank you. 28. All right. What happens to the 4? It becomes a 2. 28 breaks down into
4 and 7.
4 times 7. What happens to the 4? 2. Whew. Can we do anything to the 7?
No.
It becomes 7 and 1, but that doesn't help us any. So I'm just going to put a box around it right now so we don't forget it. Now, we have, I'm going to put over here, our variables. Anytime, when we're multiplying variables, what do you do to the exponent? You add them. So every even exponent is a perfect square. Because 6 breaks down into 3 and 3. 12 breaks down into 6 and 6. 4 breaks down into 2 and 2. 2 breaks down into 1 and 1. So you see how they're perfect squares. So and so you just take the variable and cut it in half. So if I have v to the 4th, that's like v, 2, 3, 4. What's half of that? V squared. So that's going to come out also into the playground. So now we're 3. So 2 times 2 is 4, times 2 is 8. So we're going to have 8 v squared. What's left inside the radical? 7. Did that make sense? Break the variable in half, or the exponent in half. Leave whatever can't be a perfect square. And then you know how to do the number part that comes out.
And so if you have a variable that's like 6, then you can just break it down to 3 and 3.
The exponent. Yeah. Now, there is a rule about the absolute values. You do 19 and then we'll talk about the rule. So break 343 down. Okay, what's that other number that I've suggested y'all use from time to time? I'd go for that. 7 works. Because none of the others, the 2s, the 3s, the 4s, the 5s, 6, none of those will work, but 7 will.
I can't say that. Could you say that a little louder, Rhodes?
You think 7 and 49
I
roads?
believe so.
I think let's do 7 and 49.
Oh, thank you, Rose. You're really good at math.
I wonder why.
I wonder why.
Hey guys.
You do.
Hey, now.
Why?
Y'all, it's recording.
Oh.
Okay?
Wait, why does it matter that it's
It doesn't. Just saying. Just don't go anywhere weird. All right, 49 breaks down into what? And what about the 7? We can't do anything with it. Now, let's look at the variable. We have a k. We can't cut it in half. K's exponent is k1, so it's just going to stay under. So your final answer will be 7 radical 7k. Did that make sense? All right, here's the deal with exponents. If you have an even exponent, you know they break down. That we've already established that. If the exponent, though, ends up as an odd number, like when it breaks down from 2, it's going to go to 1, you have to put that variable in absolute value bars so that we know it's not negative. Because -1 times negative, like a negative k times negative k will give us a positive k, right? K squared. But you need it to show that it never was the negative option. Because that would mean if you broke it down and you had a negative, you would have an imaginary number. And we can't have that. So, 48. What are we going to break 48 down into?
6 and 8.
6 and 8. It would. 6 is what? 3 and 2. 8 is what? 2 and 4. What does the 4 become? A 2. And then these 2's that stand next to each other, what do they become? A 4, which breaks down to a 2. All right. We're through with the number. Anything remain? We're going to leave anything behind? The 3. I'm going to put a box around it for now. Maybe I'll do like this because I already have a box around the 2 2. So we know that 3 is staying. Now let's go work on variables. So one of them would be an M. Can we do anything with an M? It's going to stay. What about n squared is n times n? And so we can remove that. It's a perfect square, and it becomes an n over in the playground. Now, because it went from an even exponent of 2 to an odd exponent of 1, that variable goes inside an absolute value bar. So your final answer, move that up a little bit. You will have, and remember 2 times 2 is 4. We'll have 4 absolute value in radical 3m. 4 absolute value in radical 3m.
So anytime you move a variable that's squared to the outside,
Or an even
an even
to
variable,
becomes an odd.
that becomes an odd, you gotta put the right.
Like radical 6, x to the 6th would be
become
x
radical.
cubed, but you'd put it as a radical. An absolute value. So 23. Miles?
Why didn't you just put 4 in? Or is it the same thing?
She just explained that if you go from a 2 to a 1, you gotta put an absolute.
We just went through all kinds of reasons why and the whole kit and caboodle.
Because
I need you to be tuned in.
23.
It matters.
4, 23 is 4 absolute y,
Mhm.
radical x, 2x.
Yep. So 23,
4,
final answer is going to be
4 absolute.
4y, absolute value of it, and then inside is 2x. Anytime you have an even exponent and you remove it as an odd exponent, it goes in the absolute value bar so that you know it remains positive. You don't want it to have an option of being negative, because then it would mean you had an imaginary number going on. Does that make sense?
What if you remove it and it's even, like 4 and 2?
You don't. Because if you square that, it works. It's just the odds. Now, let me say this too. Huge hint for homework. You have the evens. If you end up breaking down more than one even exponent and it becomes an odd, you put them in their own absolute value bars. Don't combine variables inside an absolute value bar. Okay?
Oh, I got it.
So you'd put like S and T inside their own bars. Don't put an absolute value S times T, because that would mean multiplied and then do something to it.
I'm done with the homework, Robert.